Hi, my name is Krisha Antonio and this is my Chem 350 video assignment. And in this video, I will illustrate the free radical mechanism of the synthesis of PVC, which involves the initiation, propagation, and termination. So we will start with the initiation. The initiation process starts with the initiator, which is the hydrogen peroxide. And then with the presence of heat or light, this hydrogen peroxide decomposes or it breaks down which leads to the formation of these two OH free radicals. Moving on to step 2, which is propagation. And in this process, we will see how the polymer chain builds up. So we will start with one of the OH free radical, which will attack the vinyl chloride monomer. Now, the free radical electron will attack the space between the free radical initiator and the first carbon of the double bond. Then the upper bond of the double bond breaks down. So one electron comes back to meet it, and then the other one moves to the other side, and this reaction produces the bond between the initiator and the vinyl chloride monomer. The product of the first one becomes the reactant of the second propagation step. So let's write down the product. This is the product. I'll write it down over here one more time. Now this will attack another piece of vinyl chloride monomer, like this one right here. And then this will happen the same way it did in the first step of the propagation process. So the free radical electron attacks the space between these two right here, these two carbons. Then the upper band breaks one electron going to the left and the other to the right. Now this process will then produce this right here. And then the reaction continues. So the product of the step 2 of the propagation, we'll then let's go ahead and write that down first. So this is the product of the second step. Right there. So then this product from step 2 will react with another vinyl chloride monomer. And then working the same way as it did from the previous step. So this free radical will attack the space between the two carbons, and the upper bond will break, one electron going to the left and the other going to the right. Which will then produce this product. So we're just writing everything as one. So now we are only required to show 3 steps, but in reality it continues in n number of times, so that this polymer can end up longer than how it is right now. And then now we'll move on to step 3, which is termination. Now in termination, we'll start with coupling. So with coupling, it involves the combination of one free radical chain with another free radical chain, which forms the polymer. So then I'll just write it down right here. Basically, I'm writing down this thing right here. And let's make it shorter by putting it in a bracket. Now this just means that this chain can be longer, like n number of times. And then we'll just write it. And this has the free radical right there. I'm basically writing this same thing on the other side. And we're putting it inside the bracket one more time. So then these 2 different radical chain coupled up. They will couple up, which will then produce, I'll just write it down here. I'll write it down over here in the product. It's just a combination of both. I'm putting on the bracket since this chain that right there can be longer than how it is, but we're not gonna write down the whole thing. And then with this, so we will form a single bond in the middle. And we're just writing down everything again. This is the end product for the termination with the coupling method. So I'll erase this and then we'll go from there. Alright, so I've erased everything from earlier since I'm running out of space. So right now I am going to discuss another type of termination, which is the this proportion. Now this involves transfer of hydrogen atoms. So I'll go ahead and write down my chain first. Now this is the end product. This chain that I'm writing right now is the end product from our propagation process, since we're going to discuss the disproportion termination process at this time. Let's make sure that I have everything right. And that's it. So I'm forgetting the CR right here. Right there. Alright, so how this works is with this one right here. So the hydrogen from this bond right here is being shifted from that carbon to this carbon right here, which will, now that shift will cause two different products, one saturated and one unsaturated. So after that shift, we will have the product that we will have will be this. So it's basically everything, writing everything from here is down here, but this will be CH2 from this H because of the transfer of that hydrogen. And then for a second one, so we will have a double bond instead of a single bond because of that loss of hydrogen. I forgot to write the n number of times here and the n number of times there will be the same as this. Alright, so let's write down the fluorines. Alright, so now we have these two different products right here. So this one will be our saturated, and then this one right here is the unsaturated. Now how I know that this is an unsaturated is because of the double bond that was formed right here. So these are the two end products to the disproportion method of our termination. So now I am going to talk about the plasticizer. Now the mostly used plasticizer that I am going to show is that of the DINP, which is the short acronym for the isononyl phthalate. And then, so I'm going to draw the structure of the DINP right here. So it has 1, 2, 3, 4, 5, 6 carbons. This has 9 more carbons and 19 hydrogens right there. And same on the other side. So that's the structure of the DINP. And then for other products or things that has PVC on it, some products that I use that contain PVC are debit or credit cards, the shower curtains that we use in the bathroom, and raincoats. And so this is the end of my presentation. Thank you for your time and have a good day, Professor.